this is section 11.9. It's also 5.1 and 5.2. You'll see it labeled as 5.1 and 5.2. And it talks about standard normal distributions. Now, we talked about normal distributions yesterday, and we're going to talk today about standard normal distributions. Now, what standard normal distributions are going to do is it's going to put everything on an equal playing field, no matter how different their data is. Okay, so the objectives here are to calculate a z-score given a standard deviation and a mean. Okay, that's going to be the first video. The second video is we're going to use table A to calculate the area underneath the standard normal curve. That's going to be the second one. Okay, so let's start here with standard normal distributions. A normal distribution, it's a normal distribution with a mean of 0 and a standard deviation of 1. Okay, so as you look down at the chart down here, again, the middle, okay, what always goes in the middle? The mean does. Well, in a standard normal distribution, the mean is going to be 0. And the standard deviation is 1. So I'm going to go 1 and a 2 and a 3. And then I'm going to go with a -1, a -2, and a -3. Okay? So you see on your standard normal distribution, on a standard normal distribution, it really covers, and I'll cover this here in a little bit in a second, it really, the furthest left it goes is -3.49, and you'll see that on the next chart. The furthest right it goes is +3.49. Okay, so it really covers those data sets. And what you're going to do is you're going to have to convert your data to a standard table. Okay, where everything gets converted to the standard table, and that way we're able to now compare any two different types of data. Okay, now in order to put it into one table, we have to be able to calculate a z-score. Okay, a z-score is any x value that can be transformed by using this formula. The z-score is equal to whatever value we have minus the mean divided by the standard deviation. Okay. Don't forget also the area underneath the curve even in a standard normal distribution is still 1. That area underneath that curve is all still 1. Okay, so now let's talk about some properties of a standard normal distribution. And this is what I was just alleviating on just a little bit ago in terms of the cumulative area is close to 0 for z-scores that are -3.49. So essentially it's like reading this from left to right. Okay, so if you were thinking of this as a number line from left to right, again, this is at 0. The area over here is at 1. Everything else is in between. Okay, now so the area for 0, the area of 0 is a z-score of -3.49. The area of 1, which would cover the whole graph here, which would cover the whole curve, the area of 1 has a z-score of 3.49. So your z-scores are going to be between these two numbers, -3.49 and +3.49. 0, which is the mean, is exactly in the middle. So it's exactly in the middle here. And let's take that horrible looking line off and let's redraw that line here. So my mean is right here, that's 0, which means, again, the cumulative area to the right of 0 is going to be half, or 0.5000. The cumulative area to the left of the mean is half, or 0.500. Okay, so the cumulative area for a z-score of 0, which is exactly in the middle, is going to be half. All right, now let's go through and figure out how to calculate a z-score. Now remember, I gave you that formula on the first page of your notes. Okay, so on the formula here, we're going to take the whatever value we need minus the mean divided by the standard deviation. So it says here, scores on the Wechsler Adult Intelligence Scale for the 20 to 34 age group are approximately normal with a mean of 110, that's the mean, and a standard deviation of 25. That's the standard deviation. Okay? Find the standardized test scores of the people listed below. So I want to be able to calculate the z-score so I can put all these guys all on the same scale, be able to compare them all. So in order to find the z-score here, I take the amount that he got on the test. So Steve got a 140. I subtract that from the mean, which is 110, and I divide that by the standard deviation of 25. Okay? And you take 140 minus 110, that's 30. And if you divide that by 25, you get a z-score value of 1.2. Okay? And you're going to see later on the second video where we're going to apply that z-score to. Okay? So Margaret, she got a 90 on the test. We're going to subtract that from the average of 110, and we're going to divide that by the standard deviation. 90 minus 110 is negative 20, divided by 25 is negative 0.8. Okay? So again, you're going to have to be able to calculate some z-scores. So number 2, it says the distribution of ACT scores is normally distributed with a mean of 18 and a standard deviation of 6. So again, 2 important points here. That's the mean and that's the standard deviation. Find the standardized test scores. So we got to find when the standardized test score is the z-score. So Mike got a 35, and we're going to take that from the average and divide it by the standard deviation. 35 minus 18 is 17. Divided by 6 gives me a number of 2.83. Okay? So that has Mike got a z-score of 2.83. Kevin, on the other hand, he got a 17. So Kevin takes his 17, subtracts the average of 18 divided by the standard deviation. 17 minus 18 is negative 1. Divided by 6 is negative 0.17. Okay? Anytime you have a decimal on these, you're going to always want to round them to the nearest hundredth. And again, you'll see why here on video 2. Okay? So this concludes the first video. All right? The first video talks about the standard normal distribution curve and also how to calculate z-scores.